while Google celebrates its Willow breakthrough. IBM is quietly executing the most ambitious quantum computing roadmap ever attempted. By 2029, the company plans to deliver something no one has achieved so far: the world's first fault-tolerant quantum computer. This isn't just another incremental upgrade. It's a complete transformation of computing, one that could make today's quantum machines look like pocket calculators. IBM's quantum strategy represents a $10 billion bet on a fundamentally different approach to quantum computing, while competitors focus on qubit counts and flashy speed demonstrations. IBM is building the infrastructure for quantum computers that can run for hours. Without errors, the holy grail of quantum technology. This is what will unlock applications that are impossible with current systems. Fault-tolerant. Quantum computing is the difference between quantum computers as research tools and quantum computers as world-changing technologies. Today's quantum machines, including Google's Willow, can run calculations only for microseconds before quantum decoherence destroys their fragile states. In contrast, IBM's Starling system is designed to run quantum calculations for hours, days, or even weeks without losing information. The technical challenge is enormous. Quantum systems are extremely fragile. Even a single vibration or photon can break a calculation. IBM's approach uses quantum error correction, where hundreds of physical qubits work together to create a single logical qubit that can preserve information indefinitely. This demands unprecedented precision in quantum control and measurement. IBM's roadmap details exactly how they plan to reach this seemingly impossible goal. The Starling system will feature 200 logical qubits, capable of running 100 million quantum gates, a scale far beyond what today's quantum computers can achieve. Each logical qubit will be built from thousands of physical qubits using surface code error correction, the leading method for large-scale quantum computing. The implications are revolutionary. While today's quantum computers solve only artificial benchmark problems, fault-tolerant machines will solve real-world challenges that classical computers simply cannot handle. Drug discovery, materials science, financial optimization, and artificial intelligence will all be transformed by error-free quantum algorithms. IBM's approach differs fundamentally from competitors like Google, IonQ, and Regedy, while others focus on headline-grabbing quantum supremacy demonstrations. IBM is building quantum systems that enterprises can use right now for meaningful business problems. This enterprise-first strategy is already paying off. IBM has deep partnerships across finance, pharmaceuticals, and technology. HSBC, for example, achieved a 34% improvement in predicting bond trading outcomes using IBM's quantum computers, the first real demonstration of quantum advantage in a financial market application. This wasn't a lab test. It was a production-scale trading model running on real market data. IBM's quantum network gives it another competitive edge. Through this network, more than 200 organizations access IBM's quantum systems via the cloud, creating a global ecosystem of developers, researchers, and enterprise users. As quantum computing shifts from research to commercialization, this network effect becomes a major strategic advantage companies already using. IBM's platform will be positioned far ahead when fault-tolerant hardware arrives. In essence, IBM is building the quantum equivalent of Amazon Web Services, a platform that becomes more valuable as more users join IBM's journey toward fault-tolerant quantum computing follows a precise roadmap with clear milestones. It begins with the upcoming Nighthawk processor in 2025, featuring 120 high-connectivity qubits capable of running 5,000 quantum gates. This represents a major leap in quantum circuit depth and complexity compared to today's systems. By 2027, IBM plans to scale Nighthawk into modular systems with up to 9 120-qubit modules, creating quantum computers with over 1,000 qubits. This modular approach allows IBM to expand quantum systems incrementally while maintaining the high connectivity and low error rates necessary for fault-tolerant operation. The technical challenges IBM faces are unprecedented in computing history. Quantum error correction requires measuring quantum states without destroying them, correcting errors faster than they occur, and preserving quantum coherence across thousands of qubits simultaneously. Each of these challenges pushes the boundaries of physics and engineering. IBM's solution involves revolutionary advances in quantum control electronics, cryogenic engineering, and quantum software. The Starling system will operate at temperatures colder than outer space, while maintaining precise control over thousands of quantum bits. The engineering complexity rivals some of the most ambitious projects in human history, from the Manhattan Project to the Apollo program. The economic implications of fault-tolerant quantum computing extend far beyond IBM's business prospects. McKinsey estimates that quantum computing could generate $850 billion in annual value by 2040, with fault-tolerant systems capturing the majority of this market. IBM's early lead in fault-tolerant quantum computing positions the company to dominate this emerging industry. The strategic implications for national competitiveness are equally significant. Countries with access to fault-tolerant quantum computers will have decisive advantages in cryptography, artificial intelligence, material science, and drug discovery. IBM's partnerships with the U.S. government and allied nations are forming a quantum alliance that could reshape global technology leadership. IBM's quantum strategy also includes quantum-safe cryptography initiatives, which will become critical as quantum computers near the capability to break current encryption methods. The company's post-quantum cryptography standards are already being adopted by governments and corporations preparing for the quantum cybersecurity challenge. IBM collaboration with AMD to develop quantum-centric supercomputing reflects their vision for the future. Hybrid systems that integrate quantum and classical processing seamlessly. These systems aim to solve problems that neither quantum nor classical computers could tackle alone, creating entirely new categories of computational capability. However, IBM faces significant challenges in executing its fault-tolerant quantum roadmap. Google's Willow breakthrough shows that competitors are rapidly advancing in quantum error correction. Meanwhile, Chinese quantum research programs, backed by substantial government funding, are pursuing similar fault-tolerant approaches. The race for fault-tolerant quantum computing is intensifying quickly. Technical risks remain substantial. Quantum error correction has never been demonstrated at the scale IBM envisions. Maintaining quantum coherence across thousands of qubits while performing millions of operations may prove insurmountable. Even minor delays could allow competitors to achieve fault-tolerant quantum computing. First, IBM's plan to deliver fault-tolerant quantum computers by 2029 represents the most ambitious technology roadmap in the quantum computing industry. Success would establish IBM as the leader in the most transformative computing technology since the transistor. Failure could hand quantum leadership to competitors, potentially costing IBM its future position in computing. The next 4 years will determine whether IBM's methodical, enterprise-focused approach can deliver on its promises. The stakes couldn't be higher. The company that achieves fault-tolerant quantum computing first will shape the future of technology, science, and human knowledge for decades to come. What do you think about IBM's chances of achieving fault-tolerant quantum computing by 2029? Will their enterprise-focused strategy give them an advantage over Google's research-driven approach? How might fault-tolerant quantum computers impact your industry? This is ClickFuture, where your future is a click away. Share your thoughts in the comments below and subscribe for more coverage of the quantum computing revolution.